In this lecture, we're going to be setting up a program in Java for those of you who like networking, right? Basically, they're going to be setting up like an IP address, kind of, sort of, but it's more of, we're just going to call it bits. So it's going to be a bits program, and we're going to basically take the output of like 0 and 1 and be an on off. Much like we did before the last video when we did conditionals, or conditions rather. So let's type up our program. Okay, here's our program called, we're going to call it, the program is going to be bits. So it's going to be like a bits.java, right? So here's, I just want to explain this to you, right? So for instance, the integer, we're going to put IP version 1 or IP1, if you will. So the 192. So typically any IP address is 192.168, etc., etc. Okay, let me explain this, right? So integer, IP1, it can be anything. It doesn't matter what it's named, right? As long as it's not the same name as this one right here. That's why it's 2. Then you have the 192. So what happens is, whatever number you put in here, doesn't matter what it is, what you're going to see is the system out is going to print like a flag. For instance, in the IP range, you might see listed as 192.168.1.1. So the dots in between represents 8 bits. So the flag 8 means there's 8 bits. So each bit in a networking scheme means something. So the 8 bit, which is basically like here bit, that's like 1, 2, 3, 4, 5, 6, 7, 8. Is that 8? So the IP would be, that's 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that's an IP address. No matter what it is. Doesn't matter what it is. That's actually a 0. So that's all off. That means it's 0.0.0.0. That's a broadcast? No, that's not a broadcast. Could be, yeah, it could be a broadcast. Well, a traditional broadcast really is everything on 1. If you have all ones, that's 255, 255, 255.255. So let's just play this out a little bit. So just give you a little representation here. So for instance, these bits, these 8 bits here, they mean 8 bits. So the very first bit in the IP scheme, of course we're doing a Java program, but I'm just going to tell you a little bit about networking, if you will. The very first bit stands for 128, or if it's 1 completely, it's 128. It's either on or off, right? Second bit is either on or off. That's 64 or 0. 32, 16, 8, 4, 2, 1. It's not uncommon to see something like this, where you might have not all the, not every bit is on, but not the same in row is on. So that's common as well. That just means this bit is worth this much. So in our case, 192, so what's going to happen is it's going to turn on, say for instance 192, so it's going to do the 128, it's going to do that one, that's going to be an on, that's going to be an on, and then 128 plus 64 is 192. Let's do the math. 128 plus 64, 192. So what you're going to see in the very first example is flag 8 or bit 8, this is 8 right here, is going to be on, which is a 1, right? It'll look like this, really representationally. And then bit 7, or flag 7, is 64. That's going to be turned on as well. So what you're going to see is it's going to look like this. 0 and 0. And finally 0. That's what you're left with. And same thing with 128 and then 1 and then 1. So in our case, 1, it's just going to have the last bit as a 1. This is how every single IP4, IP version 4 IP works in the whole world, no matter what. Every single IP in the world, IP version 4 works this way. So it's 8 bits. So there's 4 times 8, so it's 32 bit. So it's 8 bit, 8 bit, 8 bit, 8 bit. And the bits have a number associated with it. It's either on or off. So this is just a demonstration of that in a form of Java program. And since we did the little / thing there, it's not going to calculate it as a program, or it's not going to calculate it. So let's get rid of this. Let's clean up our code a little bit and clean up that a little bit. Okay, and get rid of okay. It's fine if you leave spaces. That's no big deal. Okay, and finally here. Good, awesome. So looks like good. Everything looks fine. It's either on or off. So again, this means the flag 8. So that's what you're going to see actually. So system out equals, or system out is the flag, which is just going to be a flag. The IP1, so that's this version. And this little thing here, this little AND symbol, right? That means, so that means that's an AND, right? Let me just draw that. So in our case, the 192, okay, and it's just represented by and the 128. So basically both bits are 1. So what you're left with is this. So it looks like this, right? So greater than 0. So 1 and 1, that's 1, is greater than 0. It looks like this. Is 1 and 1 equals 1. So there's bits here, that's a 1. So what you're left with is 1. Is that greater than 0? And here we're left with, if it's true, turn on. If it's false, turn off. So 1 is greater than 0. True. So true. 1 is greater than, 1 is greater than 0. True. That's on. In this case here, it'd be 1 is greater than 0. That's on. Well, you might be asking yourself, how on earth does it know flag 8? How does it know that? How does it know that? Well, because the actual flag, so the flag is an actual program, right? So it's an actual program. So it's like it knows the point of, so I can probably actually just move these out of order and be fine. Matter of fact, let's do that. Let's put 8 at the very bottom here. So that way you see it's the flag itself. It's actually the flag. So what's going to read is there's going to 1 and a 1 at the end, right? So that tells you that this word here, flag, it's like, okay, flag position number 7. Oh, okay, I know it's this one right here. Oh, flag position number 8. Oh, I know it's that one right there. So let's run our code here, compile it first, actually, compile. So compile. Okay, perfect. Now let's run the code. And let's see here. Okay. All right. Oh, I didn't save it. Excuse me. Okay, it's been saved. Let's clear the screen. Run it again. Okay. And then we'll run the program. All right. So same thing here. Flag 7, it knows, okay, I know flag 7. Yeah, that's the second position. 6, right, and 8. Okay, I know it's on because it's down. You know, it knows the position, right? The same thing here as well. So at the very bottom, I flipped them. So what you have is you have 1 through 8 instead of 8 through 1, just to show you the difference, right? It doesn't really matter. It knows, okay, flag 1 equals this. So what I wanted to allude to is this, basically. The flag, so 192 and 64, if they're both 1, that's 1. 1 is greater than 0, so that's true. Yep, put a true. If it's false, put a false. And since the program knows, okay, I know there's a bit here, meaning flags like, okay, position number 7, there's something there. Okay, good. And there's something there, 64-bit. Yep. Okay, that's a 1. Good. Okay, flag 6. There's nothing there. I mean, sorry, there's something there. That's a 192. And there's nothing there in the 32-bit. So that's 0. So 0 is greater than 0. That's false, because greater is not greater than 0. So that's false. That's why it's off. So play around with these programs. It's kind of cool, actually. You know, a little bit of networking here, basically in the coding realm or Java realm, and just have fun with it, right? So I'd like to thank everybody for viewing this tutorial. Please like the channel, or please subscribe to the channel. So thanks again. Have a great day.